Hey friends, my name is Z and you're watching CIE Makes It Easy. And welcome to a new video for IGCSE Add Maths, and today we have logarithms or logs, and we'll cover normal logs and natural logarithms. And we will look into the rules and examples for logs in this video and questions for the next video. And before we get right into it, don't forget to leave a like and subscribe and ring the notification bell so that you don't miss out on any future videos. But anyways, here's some basics for logarithms, or logs for short. So we have this really simple log equation, or like expression or equation. So we have this whole thing is equal to this, is the same equivalent form. So you can see how they relate together. We have this b right here, and then we have an a which is in the bracket, or sometimes not in the bracket if you don't want to write a bracket. And then we have c. So it involves three different constants. So it's the same equivalent form. When you're trying to find b to the power of c equals a, when you're trying to find what a is, or you're trying to find what c is, you can just put it into the form of, like, you can put it into this log form into a calculator to find what c is. For example, if you have 2 to the power of 5 right here equals 32, we know that it's equal to 32. We can put into the calculator of log base 2 and then to the bracket of 32, which is what it's after, to the power of. And basically what it equals to is the power that it requires to raise the base to get the bracket. So for example, it could be 5 to the power of x equals, let's say, 6. We're trying to find what x is, and we can't just do like 1 or 1.2 because it will be too hard. So you can put in your calculator, it will equal to log base 5 and then brackets 6 equals x. And this is how you find x. And let's just color code this. 6, and then the 5. So for the terminology, you call this at bottom one a base. So we'll move on now to some rules for logarithms. There's quite a lot as well. So for the first rule, we have log base b and then bracket mn. It's equal to log base b m plus log base b n. So it's kind of like the opposite of indices, where like times is equal to plus for the power. In this case, plus is equal to times. It's a bit confusing. So let's say we have, let's just reverse this. It's the same. So let's say we have log base c 5 plus log base c 6 is equal to log base c 5 times 6, which is just 30. So let's just highlight this. Remember that all of these, the base, are the same in order for this to work. And then we have this m, and then we have this n and n. So notice that it's a plus. And for number 2, it's kind of the same, but it's divide, m divided by n, m over n. It's equal to log base b m minus log base b n. So it could be log base c 5 minus log base c 6, which equals to log base c 5 over 6. So you can see that plus together equals times, and minus together gets us a divide. And then we have number 3. We have log base b m to the power of k equals k log base b m. So what this is that you can actually just pull down the let's just change color. So this is that you can just pull down the power to the front, like from here. You can just pull it down to the front to get us a k in the front, and then log base b m will remain itself. So it could be log let's say 3 to the power of 4 to the power of 5. It will equal to 5 log 3 to the power of 4. So it's quite useful in some certain circumstances, like if you're trying to like simplify it to the fullest, or if you have a negative power, or like a 1 over something for the inside the bracket, you can actually do it like to the minus of something, and that minus could put it to the front of the log. Then number 4, we have, as I said just now, you have let's say you have a 1 over something in the bracket, it will equal to a minus power, and that minus power could pull to the front, just like what we did in number 3. And then number 5, we have log base 1 over a, b, and it's similar to number 4, where you can just pull the power up to minus. So log base 1 over ab equals minus log a b, log base a and b. So like it could be log 1 over 3, 6, will equal to, let's just rewrite this, it's a 3 over 3, 6 is equal to minus log 3, 6. Then we have number 6, we have log base a, b times log base b, c, and it equal to log base a, c. It's kind of like a chain rule, where you have the b in the middle cancel out together, that b and b they cancel out, and the c remains here. So notice that it's a times and not a plus, it's a times. So for example, it could be log base 3, 5 times log base 5. It has to be the same. Log base 5, 7. This will equal to log base 3, 7. So that's one thing to note about, and it will be quite useful in some circumstances where you're trying to simplify it by timesing both sides by something. And then number 7, we have this log base a to the power of n, and then in the bracket it will be a to the power of n. This will equal to n over m. So we don't see it much too often if you have just a simple number, but if it's a large number where you can simplify it to a power, then it'll be quite useful. For example, log base 5 over 2 equals 5 over 3. So note that it have to be the same base, 5 and 5, equal to 3 over 2. And then lastly, we have this quite a trick one. Log base b 1 equals 0, because we know that from the basic just now, the base here, this base to the power of this equals this, and anything to the power of 0 will be equal to 1. So it could be log base a, b, c, d, e, and brackets 1, it will still equal 0, because anything to the power of 0 equals 1. So it's a trick question. So let's say we have log base 999, and then in the bracket we have 1, and then it will still equals to 0. And then here we have more rules for logarithms. We have, let's say, a to the power of log base ak, it will just equal to k. So it could be 3 log 3k equal to k. And then we have this number 2, log base b will be equal to 1, because we know that b to the power of 1 will be equal to itself, so it will equal to b. So whatever, if the base and the brackets were equal to the same number, they will equal to 1. So next we have log to the base a, b. If you reciprocate it in a way, it becomes 1 over log base b, a. So basically the base, they flip or they reciprocate it right here. And then lastly, here we have a similar example to just now, where you have log base b and then brackets b to the power of k is equal to k. Because in this case, you would pull the power down to the front, is equal to k log b, right? So we know that log base b and brackets b will equal to 1 from here. So it's basically just k times 1 or just k. And you can spot this every time where you have the same base and the same like power base over here. And then we have more rules for logarithms, which is the change of base and its proof. So we have this log right here, log base a and b. So if you want to like change the whole log into another base, like let's say to change it to c, we can apply this change of base rule. Firstly, we have to set what new base you want. Let's say I want a base c, so we have to like make sure we know that c is the one that we want for the base. So you will kind of split this log up into two, like this. The top goes up and the top goes down because the final answer would be like a fraction. So it's kind of a hint where the b will go up. So log new base is c, and the b will go up, and log a new base of c, the a will go down. So this is how it works. So let's just highlight this. B will go up, and the a will go down, and c is a new new base. And here's a proof for the change of base formula. So we're going to set x equals log a b. And we know that this is equal to a to the power of x equals b because that's how logarithm works. So let's just take both sides. We're going to set a new log base. So let's stick to c. So we're going to do log c a to the power of x over log c b. So we have this power right here. We can, from the previously, we can just bring it down, become x log c a equals log c b. And finally, to just simplify this, or to find x, we can just rearrange the equation to find x equals log c b, and divide both sides by log base ca. And that's our final answer, which is just equal the same thing, which is quite cool. And then we have some rules and special case for logarithms. We have this log base a and the brackets minus b. It's unsolvable because you can't have like a power that's equal to a negative number. So let's say if you have a log base a minus b equals x equal to 8x minus b. There's no real value for x, which gives us a minus. Let's say we have like 3 to the power of x equals minus 9. There's no real value for x, which gives us a minus 9. And the same thing for number 2. It's kind of the same, but it's just a different. We can't have a minus ax, this. We can't have a power of x, or like a real power of x that gives us the value b. So it's unsolvable. But for number 3, we have this minus a and minus b is solvable because minus a, we can like just equal to minus b. It's solvable because in this case, both of the numbers, they are both negative, and it's not like one's negative and one's positive. And then number 4, we have log base 1x, where x has to be bigger than 1. It's unsolvable because if we run it out, we have log base 1 x equals, let's say, a, and we can rewrite it into this, right? So we can see that if s equals 1, a can just equal to 1. But if s is bigger than 1, you can't have any like values, because a 1 to the power of whatever, like 1 to the power of whatever, it will just equal to 1. So x has to be 1 or else it's unsolvable. Then we have some examples for logarithms. We have question number 1, log base 2 2x plus 1 equals minus 3. So you can just convert this into normal form. 2 equals 2 to the power of minus 3. Just rewrite this. 2 to the power of minus 3 equals 2x plus 1. So it will equal to 1 over 8 equals 2x plus 1. So this equal to 1 over 8 minus 1 equals 2x. And if you simplify 1 over 8 minus 1, you'll get minus 7 over 8 equals 2x. And to solve it off, or to finalize it, you can divide 2 by both sides. Therefore, x equals minus 7 over 16. And then question number 2, we have this log question right here. Log base x 8 equals 3 over 2. So you can convert this into normal form, which is just x to the power of 3 over 2 equals 8. And to get rid of this power for x, we have to times this power by something to become 1. Kind of to neutralize a reaction in chemistry where you have an acid and a base. So 3 over 2 as a power have to times another power to become 1. So you can just do 1 divided by 3 over 2, which is 2 over 3. So you have to do x power 3 over 2 times 2 over 3 as a power. And whatever you do to the left hand side, you have to do to the right hand side. So 8 has to be divided, 8 has to be to the power of 2 over 3 as well. Then it will become x equals 8 to the power of 2 over 3. And of course we have to simplify it to its fullest. So we know that, So we know that we can just cube root 8 to get rid of this over 3. So cube rooting 8 will be equal to 2. So 2 to the power 2. So we know that x equals 2 to the power 2, which will give us a very nice answer of, therefore x equals 4. So just take a moment to look at this, to understand it. Then we'll look into more examples. We have this question, and number 3. It might look complicated, but we can simplify it first before proceeding. And let's rewrite this. 3 log base x plus 2, 4 minus 2 log 5, 1. So first thing you can notice is that this thing right here, log base x is just equal to 1. Right, 1. And here, log base 5, 1 is equal to 0. Because we know that 5 to the power of something has to be 1, and that something, the power, is 0. So let's simplify it to 3 times 1, which is just 3 plus 2. And in the bottom, 4 minus 2 times 0. 2 times 0 is 0. So it will just be 4. It's 4. So it will be 5 over 4 squared, which is just, final answer, 25 over 16. And that's our final answer. And then lastly, here we have this example for logs. We note that there's a normal number without a power, and we have 2 powers. So in this case, we can use one of the rules by dividing both sides by 5 to the power of x. So 4x divided by 5x equals 9. And we know that if we have both x together, we can group the x together. But in this case, we can just do this. And just pull the x out of both 4 and 5, because if you expand this, it will be the same form. This and this, they equal the same thing, because you can just times x as a power to 4 and times x as a power to 5, it will equal the same thing, equals 9. And therefore x is just equal to, let's change the color, log base 4 over 5 9 equals x, and that's our final answer. And then moving on, we have another section for logs. We have natural logarithms. We have some basics for it. So we have this notation for natural logarithms, ln, or we call it ln or ln, but I prefer to call it ln. And ln is actually just equal to log base e. So anything let's say log base e will equal to ln. And if we have log base 10, we can just write it as log, because the default for log is log base 10. So that's one thing to note about. So we have this log ln bracket a equals c. You can write it as log base e a equals c, and c is the same thing. This equals this. And then to convert it into normal form, we can do e to the power of c, like e to the power of c here, to become this, equals a, which is in the bracket. And then here we have an example. It's a bit incorrect. Let's just change all of the 5 to x. And that way we can solve for x. So we have, let's just rewrite it over here so it's more clear. E to the power of x equals 32. So we're trying to solve for x, right? So we're going to take log base e to both sides so that we can cancel out the e on the left hand side. So it'll be, basically log log, log, you can write it as lg as write it as a short form. So it'll be log lg base e ex equals lg base e 32. So now that we can just pull the power down from just now, this x we can just pull it down to the front. It will become x log this equals log 32. And the left hand side it will just become x because lg log base e and e are equal to 1. And then on the right hand side, lge can be simplified into ln. So you have a final answer of x equals ln 32. So we have some rules for natural logarithms. So we have the inverse of x squared is equal to root x, because one's like to the power of 2 and one's like to the power of 1 over 2. So the same idea of x squared inverse equals root x, the inverse of e to the power of x equals ln x. Because if you have a graph over here, and the graph of e to the power of x will look something like this. And then for logarithms, or ln, it looks something like this. So we're going to write ln x and e to the power of x. So we know that from just now, ln is the same as log base e. And then from here, e to the power of ln x will equal to x, which is one of the rules just now we see in logarithms, where it's just like a random number. And we know that from ln e to the power of x, we can just pull the x down to the front to become x ln e. And this ln e is just equal to log base e, which is 1, which means that this is equal to x, which is what we have here. And this is just a description of what it looks like. And then lastly, here's some examples for natural logarithms. We have question number 1. E to the power of x to the power of 2 equals 312. It looks a bit complicated, but we'll break it down. So ex squared equals 312, not 302. So we're going to take ln to both sides. Ln ex squared equals ln 312. And you can pull the power of x squared down to the front, and the ln e will cancel out. So it's just equal to x squared equals ln 312. And to solve for x, you have to you have to square root both sides to get rid of this square right here. So the square root of x squared equals x, and the square root of ln 312 will just be the square root of that. You can't simplify it further, so it'll just be this. And some people prefer to write a bracket, and some people don't. And I like to write brackets because it looks like much neater. And then lastly, here's the last example for natural logarithms. We have 7 plus 3 ln x equals 5. So we're gonna just divide minus 7 by both sides, which will equal to ln 3 ln x equals minus 2, and divide 3 by both sides, ln x equals minus 2 over 3. And we can rewrite ln by log base e because we're trying to find for x. Yes. So to convert this log into its normal like form, we'll do like e to the power of this equals x. So that's how we solve for x, which is just x equals e to the power of minus 2 over 3. Well, let's just rewrite this. 2 over 3. And that's how we solve for x. And that's it from this video for IGCSE and Maths, but today we look into logarithms and natural logarithms, or logs and natural logs. And I hope you'll find it useful and helpful for this rules and examples video. And if you found it helpful, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And if you have any comments or constructive criticisms about my videos, just drop them off in the comment section. Or if you have any questions about maths or any topic questions or any questions about logs, you can drop them off in the comment section as well, and I'll reply to them. And don't forget to check out my Instagram in the description for more daily content. And if you need any resources or any lesson slides, you can check it out in my website at in the description, or you can check it out in the browser at www.makesiteasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video for logarithms and natural logarithms questions only, probably from Dr. Frost Math. But until then, stay safe and happy learning.